Declaring object reference, I think we already went over that. Oh, this is actually that. Yeah, okay. Copying variables of primitive data types. It's actually pretty straightforward. We talked about this a little bit already. You just copy them. It just moves them in memory. So when you copy C1 to C2, and this is, oh, these are object types now, right? Because these are different circles. So for simple types, it's really simple. It just copies the value. When you do this to objects, it's a little different, actually, the way it works. It actually assigns the memory location to there because objects are complex data types, meaning there's more to them than a simple value. So, if you look at bicycle, for example, it's got two data types, and it's got all this logic and rules behind it as well. So it's not a matter of just a simple value. It's not. An object is more complex than a simple value. So whereas a primitive type is a simple value, objects aren't. So what happens with objects is that in primitive types, the value is literally copied to the other memory location. So the memory locations for I and J are distinct. They are separate places, and they remain separate places even afterwards. Right? So 2, the value of 2 is copied from J to where I is pointing in memory. Objects work differently. When you say that object 1 is equal to object 2, now what you're doing is what you're really saying is that object 1 points to the same memory location as object 2. So if this was circle 1 with radius 5, as soon as you assign it 1 equal to 2, what you're actually doing is you're taking this pointer here and moving it to the other memory location. So that's kind of important. We say that in primitive types, which is like integers, for example, you're doing a copy by value. And I think I talked a little bit about copy by value last week when I said the value is just taken. It's like a photocopy. It's just taken and moved to the other location. It's like making a photocopy. And that's okay if all you need is, say, one page. So if a friend wants to borrow one page from War and Peace, you just make a photocopy of that one page. But if they need the whole book, that's way too much to photocopy. So you give them the whole book, and you ask them not to mess it up on you. So that's basically what's happening with objects. Excuse me. I'm losing my voice here. I was a little sick over the weekend. Any questions on that so far? Hold on, I'm just looking for some cough drops. I have some here. Okay, no cough drops. We'll move on. So the memory location changes. So now you've actually got less memory because both C1 and C2 are pointing to the same place in memory. That brings up something called garbage collection in Java. Garbage collection basically is a functionality of Java that will go through memory that Java has been using every so often and look for memory that no longer has an object reference to it. Because that can happen. What can happen if we go back here is if C1 now points to C2, what happens to this memory that was originally allocated for C1? Well, unless C1 knows how to properly clean up after itself, which it should be doing, but that's something you have to tell it to do, that memory could still be there. But that memory is ultimately assigned to Java, and Java knows that. So Java's garbage collection basically looks through all memory that's allocated to it and checks to see if any valid Java references exist to it. If they don't, Java gets rid of it. It basically cleans up the mess that the programmer did not clean up. And we can talk about how you clean up within your class as well so that you don't have this issue. But that's essentially what garbage collection in Java does. If you know an object is no longer needed, you really should get rid of it. And the way you get rid of it is you assign a null reference to it. Okay. JVM will automatically collect the space if the object is not referenced by any variable. The date class. The date class comes with java.util.date, and my understanding is that it has been replaced. Basically, what it does is it constructs a date object for the current time, constructs a date object for a given time in milliseconds, because dates are ultimately stored as a number of milliseconds elapsed since January 1st, 1970, which is roughly what we would call the birth date of the Unix operating system and the internet, although that's not totally true. That's just a date that happens to be a convenient date that's close to that time frame. It's not the actual birth. I don't know if people remember the original PCs. If you remember them, the default date was January 1st, 1980. I'm not even sure what they do now. But the original PCs from Microsoft, DOS-based ones, pre-Windows, it was 1180. And that's because that was considered sort of the birth date of the PC, which is not really true. PCs had been around since the late 70s, but they really started to become popular in the early 80s. So they just took the arbitrary date of January 1st, 1980 to assign as the default date for all PCs. Mainframes did it from 1970, or I shouldn't say mainframes, but sort of the Unix and the Internet related computers did it from 1970 as the convenient birth date of both Unix and the Internet, or the ARPANET as it was called back then. So we can create dates if we want, simply like this, and it will show us the current date and time. That's really easy to do. I'll go back to my just do it as part of this, I guess, and run it again. And we see if we do that, we get today's date and time when we create the date. No, it's not necessarily important. Yeah, if you're putting Bicycle and Lab4 in the same package, which is I would recommend doing, that's a good idea. You don't have to import it. Okay, so that gets us the date. And the random class is also kind of we talked about this a little bit already, but we'll talk about it a little bit more. Random creates a object based on the current time. So the random is really a pseudo-random date. The computers don't really have a way of just picking a number out of their hat. They can't do that. So they create a pseudo-random value by using the clock tick as a seed value. This is to the millisecond, so the 1/1000th of a second. It pulls that off the clock, And 1/1000th of a second is really fast. No human is going to be able to detect that. And basically uses that as a seed value to generate a number randomly. It's not really random, but because it's so fast, and because the clock can be slowed down or sped up by various things happening to the CPU and memory at the time, it would be nearly impossible to predict what number is produced. So it's close enough, and it's actually the mechanism that all types of computer games use, and casino games use, online gambling, and all that sort of thing use this random to do it. Um, Actually, an awful lot of gaming machines are written in Java. Most of the ones in Vegas are. I was actually interviewed by a company called, I think, IGT, International Gaming Technology, that built all of the gaming computers for the casinos in Las Vegas, and also wrote all the software for all the online gaming, which of course is illegal in the U.S. So they had to have a subsidiary in the Cayman Islands be the official company for that, although it was owned by the same corporation headquartered in London, England, and this is all, and of course that corporation was really funded by all the Las Vegas casinos, so it was a nice little loophole around U.S. law. They explained this entire corporate structure to me in the interview, and I did not take the job. I kind of really feared a phone call in the middle of the night telling me to pack up all my belongings and get on a plane to the Cayman Islands because the feds were going to come to my place or something. So I decided not to take it. That was probably the weirdest job interview I've ever had. But anyway, they were looking for a Java programmer who could do all this sort of random stuff, because that's the way gaming software works. And these are some of the methods that you have. We'll look at different ones. Here's an example here, random. This will pull a random number from 0 to 2, actually, and we'll print it out. I think we did this with a random character class. I mean, we can certainly just pull this out and do some random stuff. Surprised this thing doesn't give me the ability to say I want to do a main class. Java class. Main class. There we go. Okay, that just gets you the main logic there, or the main method. Could have done it ourselves, but... And this is going to be java.util.random, I'm pretty sure. So we have to fix this. And when you get this on a class and you're wondering, well, what the heck, how do I do that? One of the nice things you can do is fix imports. And look, NetBeans figured out what import you needed. And now this goes away, so you're fine. Okay. We needed java.util.random, which I knew. I just wanted to show you how to, if you don't know, and it's saying, I don't know where this thing is, that's because you have to import the class. Right-click, fix imports, does it for you. So it's a nice tool. So you got these numbers, although it looks like it came back with the same numbers each time. That's a little weird. Yeah. And it did here as well. It came back with the same exact numbers. Oh, that's because they have the same seed value. Oh, that's true. Yeah, that's right. Oh, yeah. So you really need to have different seed values. I think we don't get the seed value, I think we're okay. Then you get different numbers each time. Because if you don't give it a seed value, it's going to use the clock tick. So you get something different. Okay, any questions on any of